Hello viewers, welcome to our YouTube channel Incredible Maths. In this video, we will solve a problem asked in CSIR NET December 2023 in part C. The question area of this problem is 704073. This problem is related to finding a true statement given the matrix equation xy equal to x square plus x plus I, where x and y are two n by n real matrices. We will check the option one by one. So first we will check whether x is invertible. So for this, we will consider the given equation xy equal to x square plus x plus I. So we will take xy minus x square minus x, this is equal to I. So here we can take x, you will get y minus x minus I. This is equal to I. So if a matrix A is invertible, then if we want to say the matrix A is invertible, there exists a matrix B such that A into B equal to I. Otherwise we call B as inverse of A. So B is equal to A inverse, or A inverse equal to B. So in this way, so here we have matrix X and this is another matrix. So when we multiply these two matrices, we get the identity matrix. So that means, so this is the inverse of X. So that is X inverse equal to Y minus X minus I. So this implies the matrix X is invertible. So the first option is correct. So next we will check whether X plus I is invertible or not. So this is for option 1 and this for option 2. So we will consider take the same equation xy equal to x square plus x plus I. So we will take x plus I equal to xy minus x square minus x. So this equal to, sorry, that's a mistake here. So x plus I equal to xy minus x square. So this is equal to, so x will get y minus x. So that is x plus I equal to 0 when y equal to x. So under the condition y equal to x, we have x plus I equal to 0. So this implies x plus I is a 0 matrix. So for a 0 matrix, inverse does not exist. So this implies x plus I is not invertible, because x plus I is a 0 matrix. Therefore the option 2 is wrong. So next we will check xy equal to x. So here third one, xy equal to yx. So from the given equation, so we have xy equal to x square plus x plus I. So from the first option, so we have proved that x is invertible. So therefore x inverse exists. So now pre-multiply x inverse on both sides. You will get x inverse x square plus x inverse x plus x inverse. So we will get y is equal to x plus I plus x inverse. Now post multiply by x on both sides, we get yx equal to x square plus x plus I. So from equation 1 and 2, we get xy equal to yx. So therefore the option 3 is correct. So now we will check the correctness of option 4. So for option 4, y is invertible. So let us let us see what happens if y is a singular matrix, that is y is a 0 matrix. suppose if y equal to 0, so then we have x square plus x plus I equal to 0. So from the given equation, when y equal to 0, xy will become 0, therefore x square plus x plus I equal to 0. So this is a second order equation, that is quadratic equation. So from this we will try to find x. So according to the Cayley-Hamilton theorem, so every square matrix satisfies its own characteristic equation. So when we consider this as a characteristic equation corresponding to some matrix X, so we have lambda square plus lambda plus 1 equal to 0. So that is sum of the roots is 1 and product is 1. So sum of the root is minus 1. So these are the form. So when we solve, so no need to solve this. So we will try to find the matrix satisfying this. So the trace is minus 1. So from this, so this implies trace equal to minus 1 and a determinant equal to 1. So that is, so we can write the characteristic equation by using this technique. Trace of A into A plus determinant of A equal to 0. So determinant of A is 1 and comparing this, trace is minus 1. So trace is minus 1, so you will take 0 minus 1. Trace is sum of the diagonal entries, so 0 plus minus 1 will be minus 1 and determinant is 1. So here we can take so anything minus. So when we find the determinant, so 0 minus of minus 1, it will be plus 1. So this can be our x. So now we will find x square. So x square will be 0 1 minus 1 minus 1 times 0 1 minus 1 minus 1. So this is equal to minus 1. 0 into 0 plus 1 into minus 1 and 0 into 1, 1 into minus 1 minus 1. So here we will have 1 and minus 1 plus 1, so we will get 0. So now we will find this one. So lambda x square plus x plus 1 will be equal to 0. So when y is equal to 0, this equation is satisfied. So this implies that, so for y is equal to 0, the given equation is satisfied. So this implies y is not invertible. Because for y is equal to 0, this equation is satisfied. Suppose if this equation is not satisfied, then we can say y is not invertible. Y is invertible. So here, since the equation satisfies for y is equal to 0, this implies y is not invertible. So therefore the option 4 is wrong. So the correct options for this question is option 1, x is invertible, and option 3, xy equal to yx. So if you like the content of this video, kindly like and share with your friends. Also subscribe our channel. Thank you.